Doing example 1b from section 6.1. So this function is a little bit different than the last one. We've got a rational function here, so I wanted to go ahead and go through the derivative process for practice here. So for this problem, we need to use the quotient rule for the derivative. So remember how that works: low, d high, so x squared plus 2. The derivative of the top function here is just 1. I'll go ahead and write that so we'll keep this straight. Minus high d low, so high function, and then the derivative of the bottom function is 2x. And then we divide all this by x squared plus 2 squared. Okay, let's simplify the numerator. We've got x squared plus 2 minus 2x squared. Divide this by x squared plus 2 squared. And we have some like terms in the numerator there, so we're going to have, I'll write this as 2 minus x squared over x squared plus 2 squared. Okay, so now remember, for finding critical numbers for a function like this, the only thing you really need to do is take that numerator and set it equal to 0. Because if you set the denominator equal to 0 here, or if you set the whole thing equal to 0, you can just, like if I set this whole thing to 0, I can just multiply both sides by the denominator. 0 times that denominator is just going to be 0. So really all I have to do is set the numerator to 0 and solve that. So if I move that x squared to isolated on one side, I'll get x squared is equal to 2. So that gives me two critical numbers. X is equal to plus or minus the square root of 2. Okay, so we've got 4 numbers then to plug into the original function to find the absolute minimum and absolute maximum values. So let's plug in the smallest of the values that we have here. Or in fact, actually, I'm missing something here. Notice that negative 2, or negative root 2, is actually not on the interval there. So really, the only one we really care about for this problem is the positive square root of 2. We disregard negative root 2 because it's not on the interval. So we really only have 3 numbers to check. So we'll plug in 0 into the original function. That's going to give us 0. We'll plug in the next number in our list here, positive root 2. If I plug that in there, let's just go ahead and see what we get. We'll get root 2 over, now if I square root 2, I'm just going to get 2, so 2 plus 2. So that gives me root 2 over 4. Okay? And then finally, the last number on this list is the other endpoint, 4. So for that one, we'll get 4 over, if I plug that in there, I'm going to get 4 squared, that's 16, and then plus the 2. So I'll get 4 over 18, which is the same as 2 over 9. So now the question becomes, well, which of these two is the larger? Root 2 over 4 versus 2 over 9, it's kind of hard to tell. I think let's just plug this in the calculator and see. We'll get f of root 2. And that is approximately 0.35. And then if I plug in 2 over 9, I get, as a decimal, 2's repeating. So this is equal to repeating 2's as a decimal. Okay, so now it's pretty clear which one of these is the larger value. It's that one, so that's the absolute maximum. And then the absolute minimum of the two that remain, 0 is the smallest one, so this is the absolute minimum. Again, this is on the given interval. Oops, absolute minimum there. Okay? So that does it for this problem.